the system the system that can exchange energy as well as matter with its surrounding is known as open system. So open system, basically we can take okay. So we will continue it again. Like hello everyone. In today's session we will discuss about the thermodynamic chapter of physical chemistry. So basically in this chapter we will discuss about basic concept like few important terminologies, few properties, few process of the thermodynamics, as well as the few definitions of thermodynamics as well as thermodynamics law. So first is like what is system. So system, that is any specified portion of a matter, which has a boundary and that is separated from the rest of the universe with that of boundary. Suppose I have this diary, and this diary, suppose it is a system. Why this is a system? Because it is having a boundary, means its cover is a boundary, and that boundary is or we can say this system is separated by rest of the universe, or we can say rest of the universe means rest of the surrounding, like around this is universe. So system are basically of three types. One is your isolated system, next is our open system, and one is closed system. So isolated system are a system that cannot exchange energy, as well as matter with its surrounding is known as isolated system. Taking the example of your thermoflask bottle, that we are basically using summer and winters to keep our water and other water, milk and other product to be hot and cold. So that is this isolated system, means the heat doesn't or we can say matter doesn't transfer from that thermoflask bottle, and it will remain as we can kept it. Like if we want to kept it like cold, it remain cold, because this is a isolated system. That is not so percent isolated system, but near to be isolated system. So second is our open system, a system that can exchange energy as well as matter with its surrounding is known as open system. So open system are basically like you are taking a cup of tea and you just cap it on your table. So what you are looking for, like after a few time you are able to see that the vapors of the tea, or because vapors of water from the tea can expel out, and after some time the tea got cold. So there is a exchange of energy, means like before the tea, like before tea is hot, and after tea that become somehow less hot, or we can say cold. And next is matter, like the evaporating water or the evaporating component that contain a water molecules as well as tea molecules, that is a matter, or we can say it is a open system. Next is next system, that is your closed system. So closed system is a system that can exchange energy but not matter. In this we are not exchanging the matter with its surroundings. Suppose like same example, like you are taking a cup of tea, but you just put the, we can say, cover on it, like you don't want that evaporation take place, or you just want that the cup of tea that we are taking is take longer time to that down its temperature. So that is your closed system. Closed system are those systems in which there is an exchange of energy but doesn't matter. Same is like if you are taking a cup of we can say you are taking a glass of water, like warm water, and you are able to see that the we can say vapors of the water can expel out it. If you can stop by a cover, then you are able to see that the only exchange of energy, that means our water after some time become cold. Next is surrounding. The rest parts of universe excluding the system is called as your surrounding. The rest part of universe excluding the system is known as surrounding. Like this is, as I told you, that this is system, and around this part, like me, my laptop, my room, all the things except this is your surrounding. Or we can say our universe is basically of like this system plus my surrounding. So system plus surrounding, that is our universe. Got it? So next is your boundary. What is the boundary? Boundaries are the anything which separates system and surrounding is known as boundaries. So boundaries, that is basically, as I told you, that the cover of this paper, this diary, is a boundary because it is separate. It is separating our system, that is my diary, as well as my surrounding, that is like me, as well as the air, my laptop, you, and all the things. So this is the boundary. Next is macroscopic property. Next terminology is our macroscopic property. So macroscopic properties are those properties which are associated with the large number of particles. Like macro, as the name indicates, it's large. So large number of particles such as pressure, temperature, viscosity, surface tension, diffractive index, these are your macroscopic properties, and we can say these are the example of your macroscopic properties. Next is your state variable. State variable are the state of a system that can change when any microscopic property is changed, and these properties are known as state variable. State variable, as the name indicates, it can vary. Variable means, like in your life, like you are attempting the test of GDC, or like you are attempting the like offline test, you are solving the book like Pearson and any other pharma competitive book, like our Gpat at fingertip book, pharmacist at fingertip books, whatever the book that you are preferring. So you are vary, like sometimes you can score 65 marks out of 100, sometimes you will score 75 marks, sometimes you will score 85 marks out of 100. So same is like that. These are the properties that is changed, these properties that are changed during the system. So properties are like there are two type of variables. One is our temperature and pressure, that are our independent variable, means that doesn't depend on any type of state. Like the temperature, that doesn't depend on any type of state, it is independent state variable. Next is our volume, that is depend on the state variable because it depend on the amount, like how much amount, or we can say how much area we are taking. Like taking the example of your gas, like a gas can have an infinite volume, because like suppose I am I have a gas of cylinder like LPG cylinder, just I want to switch on that cylinder. So after some time I will able to see that the gas can expel out throughout in my room. As I open the door of my room, it can go to the outside. So this can affect, or we can say this is the dependent variable. Next is state function. As we had discussed about the state variables, next is state function. So state function are those property whose values depend only on the initial and final state. Like state function are your enthalpy and internal energy are the state function. Path function are those function that depend on the path followed. Like path followed means like heat and work done. Heat and work done, these are the path followed, or we can say path function that depend on the how much like what type of path is followed. Or next is the state function that is depend on the initial and final state. Same is like in your case, your result depend on both. Like you have depend on you are a state function as well as path function. How your state function and path function, like state function are like when you had start for the Gpat and government pharmacist exam and pharma competitive exam, when you had start your preparation. And final state, like how you gain during your process, how you qualify your exam, what is your rank, on which college you had allotted, that is your final state. Or how your path function means the path that you are followed from your date of starting of for Gpat preparation until the date of your allotment of college as well as qualifying of your exam. So that is your path function. So you are both, that is your state function as well as path function. So please be balanced between the state and path function. Like don't do like that only be state function. You are not only state function, like if you are supposing that I am in like you are thinking like you are currently in the 4th semester, 3rd semester, 5th semester, just you can prepare for the 1 month, then when the exam of Gpat can decide, then I can do again hard work. That is initial as well as final. So state function in your case is not implicated, but state and path function both are implemented in your case. So next is your state functions example. Like state function are our 𝐸𝐻, that is enthalpy, entropy, Gibbs free energy, temperature, pressure, volume. And path function that I told you, that is work done and heat, that are your path function. So next is our extensive property. Extensive property are those property of the system that depend on the amount of substance. We can say that depend on the amount of substance, like how much amount of substance we are taking or how much amount of substance is present in a system. So extensive property are the mass, volume and entropy change. Like extensive property are depend on the amount. Suppose we have amount, like I have 100 ml of water and the volume of water is I have 100 gram of water and the volume of water is 100 ml. Same is like entropy change. Next is like our intensive property. So intensive properties are independent on the amount. So intensive properties, suppose we have density. Suppose we have two glass of water, one is of 50 ml, one is of 100 ml. So we know water is having the density of 1. So in this case, these property, intensive properties are those property which are independent of the amount of substance. Like it don't depend like it is the water from your tap or water is from your camper. It doesn't depend. Like it doesn't depend on the amount, like you are taking 5 ml of water or 500 or we can say 500 ml of water. So it not depend on the amount of substance present in your system. Just depend on we can say it independent of the temperature. Like our pressure. Suppose same is your example, like pressure. If you are having a like if you are taking a specific amount, suppose you have 5 gram of pressure, you have 5 gram of a substance and the pressure is 1 atm, 2 atm. It doesn't depend like you can take 10 gram of substance and it's pressure get increased. No, same is like on viscosity. If you are taking the if you are taking a 5 ml of water and 100 ml of water, it doesn't depend that 100 ml of water contain more is more viscous than the 5 ml of water. But it so next there is a difference between the extensive and intensive property, as extensive property are depend on the amount or we can say amount of substance present in the system. Intensive properties are independent, like your molar volume, density, pressure, temperature, concentration, boiling point, freezing point, surface tension, viscosity. Boiling point, like taking the example, like your water boil at 100 degrees Celsius. If you are taking 100 ml of water, that boil at 100 degrees Celsius. If you are taking same amount of water, that is you can say if you are taking different amount of water, that is 1000 ml of water, it will also boil at 100 degrees Celsius. So it doesn't depend on like amount. One important concept, like extensive properties are added. We can add. How we can add? Suppose like volume V1, and that is we have a volume of NaCl. We can say we have volume of HCl. HCl volume is our 5 ml, and next HCl that is having different volume, that is V2, that is 50 ml, 10 ml. So I want to add these like V1 plus V2. So I will get 15. So extensive properties are added. Same is like if you have a specific amount of sugar, like you have 5 gram of sugar from different source, 5 gram of sugar of different source, you can just add and it become 10. Like in this example, intensive example, if you are taking 100 ml of water and 1000 ml of water, and 100 ml of water as it is having the boiling point of your 100 degrees Celsius as the same that is your 1000 ml of water, but if you are adding, the volume can be like 1.1 K, like 1100, but the temperature doesn't mean like it would be 200. So temperature cannot be added. Same is like for viscosity. So viscosity cannot be added. If you are adding two substance in different volume having the same composition, if you are adding, then it doesn't mean that the viscosity can be double. Got it? So it is about your intensive property. Next is we will discuss about the thermodynamics process, like how is our isobaric process, how is our adiabatic process, what is about your isothermal process, isochoric process, isobaric process. We will discuss it one by one. So next is first is our isothermal process. Isothermal process, these are the process in which temperature remain constant throughout the pressure process. Means a process in which temperature can remain constant. Suppose we are taking a temperature of 100 degrees Celsius before starting the process, and at the end of the process the temperature remains same. So these process in which temperature remains constant, that are our isothermal process. And all phase transition are isothermal process. All phase transition process are your isothermal process, because uh, in a phase transition, the temperature of whole the process remain constant. Next is like change in energy during isothermal process is zero, as Q in this case Q is equal to minus W, and minus Q we can say minus Q, that is heat of the process, is equal to plus work, that is work done positive. Or delta H of isothermal process, that is enthalpy of the process, is zero. We will discuss these whole terms in detail, like what is our enthalpy process, what is your we will discuss in detail like how is your enthalpy process, what are your E naught of cell, what is your we can say work done. So we will discuss these terms one by one. So next is your adiabatic process. So adiabatic process are those process Adiabatic process are those process if heat doesn't enter or leave the system during any step of the process. So these are the process in which heat doesn't enter or leave the system, means heat remain constant during whole the process. As in the isothermal, we are saying that temperature remain constant throughout the process. Same as in this case. Next is work done in isothermal expansion is more than in adiabatic expansion, because in isothermal expansion the work done by the system as well as on the system, so it means work done in isothermal expansion is more than in adiabatic process. Next is our isobaric process. So isobaric process, as baric we are using like bar, atmosphere, atm as the unit of pressure. Sorry. So isobaric process are those process in which pressure of the system during entire process remain constant. Like pressure during a whole the process, during entire process remain constant, is known as isobaric. As volume and temperature are variable and pressure in open system is a isobaric in nature. Like in open system we had discussed, like open system. So in open system pressure remain constant. Like if you are taking a cup of glass, cup of water, so temperature, or we can say pressure in the open system like our water, that pressure remain surrounding that remain constant, or we can say that is isobaric in nature, while volume and temperature that are our variables. Next is your isochoric process. So isochoric process are the process in which volume remain constant. So these are the isochoric process in which volume remain constant. As in case of isochoric, in this process our pressure and temperature are variable, but in case of our isobaric process we are discussing like volume and temperature are variable but pressure remain constant during open system. So in this process no work done during isochoric process from the first law of thermodynamics. So first law of thermodynamics tells us that work done is zero in case of isochoric process, or we can say the equation of first law is our E is equal to Q plus W. And one more thing that we are discussing, like we will discuss that work is our PV. So in this case, like pressure and volume, pressure remain constant, so it doesn't mean like the work can be changed. Got it? So next is our a cyclic process. So what is cyclic process? So cyclic process are the process when a system undergo a number of different process and return from initial to the initial to the final position. It termed as cyclic process. Suppose a process start from A and it goes to B, then it goes to C, then it it back to the D, then it back to the E, then it back to the P, then again to the A. It is the initial and final step, because the initial step is our A, because the process is starting from the A and back come to the process A. Same is in your case, like you are going from your home to college to library to you are going your friend home, and then back to the home. So your initial step in the early morning is your home, and back you are again at the home. So this is your cyclic process. If you are like looking as like acyclic process, in this case is like you are going from home to the college to the library, and back to the home, but not your home to your friend's home. So in this case your initial and final state is different. Like you can stay at your friend home or your relative home. So in that case the process become acyclic, or we can say our your in your case, in your cyclic process, there are so many type of negative vibrations, negative environment. Like you are going from home via bus, via your own vehicle, you are looking so many type of negative people, because negative people doesn't mean ki some all are negative. Like you are looking all the things, like somewhere you are looking you are watching like cinemas, movies, some type of theaters, fast food shop. So your eyes can respond, then you have to go there, because this is the only fault like our eyes want. Like we want that I have to watch the movie, I have to watch the reels. Our eyes want, our eyes see that I have to eat some type of pizza in Pizza Hut, Domino's, whatever. Same is like our tongue has order that you have to eat fast food like burger, pizza, Xiaomi, pasta, whatever your tongue said. So this is your order of your tongue, and you just take your whole the body, like your hand, leg, ear, nose, eyes, because order is done by your tongue, and you are taking whole the body, just because you had not control on yourself. You have not control on your eyes, you have not control on your ear, you have not control on your tongue. So what you are doing, because your tongue, your ear, your eyes, your mouth is controlling you. They are ordering you that listen the music, because your exam are coming soon, but you are listening your sense organ, like you are listening for your eyes, ear, tongue, that please go for this, like please watch a movie, please watch trade fair or any type of things. So please don't depend, or we can say please don't be like please don't take over, like don't be take over by your sense organ. Don't think don't listen your eyes, don't listen your ear. Always be have your positive mindset, that you know that there is a benefit of eating fast food. You know there is a sorry you know that there is no benefit of eating of fast food. You know there is no benefit of listening of bad things, bad songs. So why are you doing this? This is your crucial time, as your exam are coming soon. So please keep in your mind that you have choose those path, those follower that can motivate you, that can help in your upgradation. So use those resources that can upgrade your knowledge. Always be have adding behavior, like adding soft skill on daily basis in yourself. Got it? Don't be depend on like that ki, like our friend do this so that I can do this. Today my friend is not at my room, like if you are living in a dome in your hostel, so don't think like that my roommate is not there and he has gone to his home, so I don't read. Because your friend that had gone that their home, he has reading at that location, but you are thinking like no one can see you. If either you can watch the movie, you can see the reels, you can do anything, but National Board of Examination are watching you. They are analyze your result according to your choosing option. They can give the result according to your hard work, and somehow blessings can always play a role in your result. So always be blessed, always be thankful. Coming back to the point or next point, like what is reversible process? So reversible process are the process that carried out infinitely slowly, so that the driven force is only infinitely smaller or greater than the opposing force. Or we can say a process that can be reversed back. Suppose we have we have NaCl plus water. Just we are adding NaCl into the water, as Na is dissociated into the Na positive and Cl negative, and H is dissociated into the S positive and OH negative, and it can form NaOH plus HCl. Got it? It form NaCl and HCl. So this reaction can be reversed back. Same is in case like I had taken the example A plus B, that can leads to the C and D. If even we can change some type of external changes, then the reaction can be reversed back, means the product can be converted into the reactant and reactant can be converted back into the product. So in the reversible process, the external pressure applied by us is variable. It is not be constant. Got it? Next is your irreversible process. So irreversible process, a process that doesn't take place infinitely slowly, like the reaction that is not not following, or we can say not going slowly, is your irreversible reactions. Means like somehow some type of fast reactions are the reactions that are irreversible. Suppose the fast reaction is like that, like you are shouting on someone, if because you have a mental pressure, like someone is irritating on you, and such instant response are taken by you can be irreversible. Like you are shouting on me, you are beating on someone, that cannot be reversed because the process is very fast. Like you are shouting on that, you cannot be reversed, you cannot be reversed. Same is like in your case, like you are attempting the exam, like attempting the Gpat or other pharma competitive exam, you are, you know, you are so fast, like you are just able to see the question and then you are going on to the option and you are just correct wrong option. So after submitting your result, you come back to your from your center, you come back to your home and you are realizing that, oh shit, what I had done in the exam, this is my silly mistake. These are called human mistake. So for while attempting the question, you just have to use, like if you are you are reading the question, just take 2 to 5 seconds of pause, think what your mind responds to this, then you are able to see that your mind responds for a particular question, that this is the proper option. Then for 2 to 5 seconds later, you have to go to the option, and where you are able to see the same option, that is that is a response by your brain. So tick and that option in this so according to this, there will be great chance that you are able to correct, or your accuracy rate can be high. So P external in irreversible process are constant. Next is your entropy. So entropy, that is the randomness of your system, or it is measure of disorder of the system. Like it is measure how our system is disorder, how the system is disorderly arranged. Means it gives the relationship of heat and entropy, as heat is equal to Q is equal to T delta S. Delta S, that is our entropy. Entropy is represented by capital S sign. If entropy of a process is positive, it means it is irreversible process. Got it? If entropy is positive, it means it is irreversible process, and irreversible process are those process in which the reaction is non-spontaneous, means the reaction cannot be going regularly. There will be some type of step where we have to add some reagent, some external resources we have to add, so that it can proceed further. Got it? Next is, if delta S is 0, delta S, that is our change in entropy, or entropy, as I told you, it gives the randomness of the system. Delta S is equilibrium, like delta S is 0, that is in equilibrium. It will cause the or we can say for the reaction whose delta S is 0 is called your reversible reactions. Means the reaction is in equilibrium state, we can convert it the reactant into the product, and the product it into the reactant. Got it? One and the most important point, that is unit. So unit of delta S, that is entropy, that is Joule Kelvin minus, or calories Kelvin minus. So this is the entropy, that is denoted by the S sign, and that is having the unit Joule Kelvin minus, calories Kelvin minus. Got it? So as I had told you that entropy is a state function, and it is extensive property. Means extensive properties are those properties that depend on the matters, or we can say that doesn't depend on the matter, or we can say that doesn't depend on the that is additive in nature. So we can add the extensive property. Got it? So sorry. So next is our next concept, that is our Gibbs free energy. So Gibbs free energy, that is the change in the free energy that is represented by delta G sign. Gibbs free energy that is represented by delta G sign, and it is free energy, like how the change in the free energy, or it is a very most important critical parameter, or we can say criteria for determining reversibility of the reactions or irreversibility of reactions. By the Gibbs free energy of a reactions, we can predict that the reaction is spontaneous. If the reaction is spontaneous, what about their reversibility of or irreversibility of reactions? By reversibility and irreversibility, we can calculate the P external. As in case of reversible reactions, P external is variable, and in case of irreversible, P external is your constant. So it is used to predict spontaneity of a process as delta G is equal to H minus T delta S. So delta G, that is equal to negative sign, or we can say irreversibility, or it can give the spontaneous of the reactions. Delta G is negative, and it is, if delta G of a reaction is negative, it can show that the reaction is irreversible and the reaction is spontaneous in nature. And if delta G is 0, that means the reaction is reversible, or we can say, or that it is in state of equilibrium, means the reactions is in equilibrium state. If delta G is positive, it proves that the reaction will not proceed in the forward direction, means the reaction cannot occur, or the reaction is stopped. So by using Gibbs free energy concept, we can calculate like how is our reaction reversible, irreversible nature, and what is the state of equilibrium, or we can say our spontaneity of the reactions. So I hope you are clear with the above point of today's discussion. Please write in the comment box if you have any doubt, or all things are clear to you. Please reply if you have any doubt, or I have to repeat something again. Please reply fast. Okay, I hope all the things are clear to you. So next concept is our enthalpy, that is H. Enthalpy, that is equal to the internal energy, that is denoted by U, plus product of P and V. P and V, basically we are using W is equal to PV plus nRT. In case number of moles can 0, then work done is equal to PV, that is pressure and volume. So enthalpy, that is represented by H, that is equal to your internal energy as well as product of pressure and volume. So enthalpy, that is represented by total pressure stored in a system. Enthalpy H is represented by total energy of the system that is stored, and it is a state function, as I told you that our enthalpy is a state function. And for a particular reactions, if delta H is positive, it means the reaction that are going on is our endothermic reactions. And what are endothermic reactions? As endothermic reactions are those reactions in which the heat is absorbed by the reactions. Like during the process, the heat is absorbed from by the reactions. Means we have to supply from the outside. So all the concepts are correlated with each other. Like enthalpy is correlated with internal energy, entropy, our we can say Gibbs free energy. All the concepts are related with each other. So don't be skip any single topic. Please be active during all the lecture or during all the study time. Like you are reading a book, or we can say attempting the GDC test series, or solving the question at your level. So please be active during the hours. Don't be like that we had read for 15 minutes, then we are scrolling the leave for 5 minutes. No, don't be two work simultaneously. Like 15 minutes study and 5 minutes reel scrolling. No, don't do like this. One time, one work, that is by perfection. But you have to choose multiple option, like we can say like if you are not qualifying the exam or you are preparing, then what after this? Choose multiple option but having a single one goal. Got it? So delta H, that is positive for the endothermic reaction, as endothermic reaction are those reaction in which the heat is absorbed by the process, and delta H, that is negative are those reactions in which delta H is negative. It means it is exothermic reactions, and exothermic reactions are those reactions in which heat is evolved from the process. It is evolved from the process because if we are doing a process in a test tube and you are able to see that the test tube can become the temperature, or we can say the test tube become hot. So what you are doing, you have to cool it, you have to use water bath, you have to do ice cube to cool down the temperature. So these are the consequences of delta S, that is maybe positive, that leads to the endothermic process. Delta H is negative, that leads to the exothermic process. Got it? Next is your heat capacity. So heat capacity, it is the heat required to rise the temperature of a system from lower to the higher, and we have to divide it by temperature difference. Like Q, that is C is your heat capacity, that is equal to rise in temperature of the system divided by the temperature distance. Q is our rising temperature. Temperature difference means like T2, that is our rise temperature, T1, that is our initial temperature. And heat capacity is having the unit, that is Joule Kelvin minus, calories Kelvin minus, Joule Celsius minus, calories Kelvin minus. So please don't skip this type of unit, as there was question in Gpat 2022 and they was asking that what is the unit of conductance, resistant, molar conductivity, and they are there was a question like they are also asking for the symbols like entropy, that is represented by S sign, enthalpy S sign, Gibbs free energy G sign. So please don't this type of silly mistake, as these are the very miscellaneous question and these are rare boosting your questions. Next is your specific heat capacity. So specific heat capacity is the amount of heat that is required to rise temperature of to rise temperature of 1 gram of a system by 1 degree Celsius. Specific heat means we are specifying the amount of a substance, like we are taking 1 gram of substance and we are specifying that we have to increase this 1 gram of substance temperature by 1 degree. That is called specific heat capacity. Specific heat capacity is the unit that is having the Joule Kg minus Kelvin minus. As the heat capacity is having the unit Joule Kelvin minus, calories Kelvin minus, or we can say Joule Celsius minus, calories Kelvin minus. In this case we are taking 1 gram of a substance, so the unit that is added, that is Kg minus. Got it? Next is your molar heat capacity. Molar heat capacity is the amount of heat that required to rise the temperature. Molar means 1 mole. We are taking 1 mole of a substance and we are increasing the temperature by 1 degree Celsius, is known as molar heat capacity, and it is your intensive property. Means we don't add molar heat capacity of 2 and it doesn't depend any type of amount, like it's only on moles. Next is your unit of the molar heat capacity, that is Joule mole minus Kelvin minus, or we can say calories mole minus Kelvin minus. Got it? So next concept, like what is the relationship between calories and Joule, as 1 calorie is equal to 4.2 Joule. This is very important, as they will ask the specific transformation of formula, and there will be probability that this question will ask in the upcoming NIPER exam. They will ask like such a silly questions, or we can say you are able to see these type of questions in your aptitude part of NIPER. Just they will ask like 1 calorie is equal to how much joules, that is 4 joules. 1 liter per atmosphere, so liter per atmosphere, that is equal to 101.3 joule, 24.20 calories, 101.3 into 10 to the power 7 earth. So calculating like our 1 liter per atmosphere is having greater than our 1 calories, 1 joule, and at the end 1 earth. So this is the increasing order. Next is our Mayor's formula. So Mayor's formula gives us the relationship between the specific heat capacity at pressure as well as heat capacity at volume. So heat capacity at constant pressure and constant volume, that is Cp minus Cv, is equal to R. R is here our gas constant, and Poisson's ratio can give the ratio of Cp by Cv. Mayer's ratio give the difference between the Cp by Cv, as Poisson ratio give the we can say ratio of Cp by Cv. And for monatomic sorry, for the monatomic it is equal to 1.66. Got it? Next is our state equations variable of a reversible adiabatic process. So these are the equations variable, or we can say we can represent a particular reaction by V, that is PV gamma constant, TV gamma minus 1 constant, T gamma P1 minus gamma constant. Got it? So these are the concept, and next is our a little bit concept or a data, that when work is done in a closed vessels, is zero, because volume remain constant, and work during free expansion of an ideal gas in vacuum is zero, because P external is zero. Because P external in this case is zero, as H is equal to E plus PV, K is equal to E minus delta G naught R by T. Delta G is equal to minus RT log K, and delta G, that is Gibbs free energy, we can represent it by delta G is equal to 2.303 RT log 10K. Got it? At constant volume, we have Cv, that is delta U internal energy by temperature. So these are the concept, and you have to remind the relationship between our enthalpy, energy, pressure and volume, that is delta H is equal to delta E plus delta PV. Got it? So at constant pressure, Cp, that is equal to delta H by delta T, delta S by delta T, but at constant volume, that is equal to delta U by delta T. At constant volume, that is delta U by delta T, means that is internal energy by temperature, but in case constant pressure, the Cp is equal to delta S, that is enthalpy by the temperature. So quantum efficiency, that is a miscellaneous topic in the thermodynamics. So quantum efficiency of a reactions, we can calculate that number of molecules that are reacted divided by number of quanta of radiation absorbed, like how much amount of quanta of radiation is absorbed by a particular molecules in a particular reactions. Got it? So this is about the basic terms. Next is your Gram's law of diffusion. So Gram's law of diffusion, it tells us about the diffusion of gas. So what the law state that the rate of diffusion of a gas is inversely proportional to the square root of density of a gas at constant pressure. Like rate, that is inversely proportional to the square root of density. Inversely D1 and D2. As we know, density is equal to mass by volume. So D1 is equal to M1 by V1, and we are putting it like R is the gas rate of diffusion. So D1 we can classify D1 is equal to M1, so M1 by V1 and M2 by V2. So if volume is our same, then the rate of diffusion is inversely proportional to their molecular mass. Got it? Or we can say mass of the substance, not molecular mass. Next is your surface tension. Like what is the relationship between the surface tension and density? So surface tension, that is denoted by gamma sign, and density, that is denoted by capital D or small d. We can use both the terms. So surface tension is having the relationship like surface tension is equal to 1/4 by D minus capital D minus small d, means density of liquid minus density of vapor at same temperature is equal to C, that is constant, that is independent of the temperature. Yeah, C is having a particular volume, that is a constant volume, and that is independent of your temperature. Got it? So these are the miscellaneous topic. Now we will discuss about the laws of thermodynamics. As the wait is over, like now we had discussed about the laws of thermodynamics, like we discussed about the important terminologies, important definitions, properties, variables. After that we have discussed specific type of properties and some concept thermodynamics like entropy, enthalpy. After that, we had discussed few miscellaneous details. Now we will discuss about the laws of thermodynamics. So first law of thermodynamics, that is, sorry, the law that is zeroth law of thermodynamics, that tell us the existence of the temperature. This law tell us that there is a temperature exists in the process. The statement of this zeroth law of thermodynamics is that it states that when A, that is in equilibrium with B, and A is equilibrium with C, then B and C both are thermally equilibrium with each other. Taking the example like this, suppose this A is in equilibrium with B and this A is equilibrium with C. So both B and C are in equilibrium with each other. A is equilibrium with C, A is equilibrium with B, so B and C both are equilibrium with each other, and these whole triangles is known as thermal equilibrium. These whole triangles is known as thermal equilibrium, or we can say this is also known as zeroth law of thermodynamics. Got it? Next is our second concept, that is first law of thermodynamics. First law of thermodynamics we had discussing about in our 11th and 12th class in the thermodynamics chapter, that law of conservation of energy, principle of conservation of energy. We had discussed a line that energy can neither be created nor be destroyed. It can move from one form to another form. Same is this law state, like this law state that the energy of a process remain constant. It cannot be converted, or energy cannot be converted nor be destroyed. So the equation of this law, that is Q is equal to U plus W. Q is heat, U is internal energy, that is our W is your work done. So work at the constant volume is 0. As I told you, work is equal to PV if volume is not changing, like work is equal to P1 V1 minus P2 V2. So volume is not changing, that leads to the work to be 0. Or we can say this law is having some type of limitations, as it is not explaining that unidirectional nature of a chemical reaction. It doesn't explain like how the reaction can be unidirectional, like how the reaction can proceed in a one direction, and it doesn't explain the conservation ability of energy of one form to another form. It doesn't explain like I am speaking in front of you, I am wasting my energy. It doesn't explain like how much extent of energy is conserved. It doesn't explain like I am teaching you and how much amount you are getting. So this is not explained by this law. Same is like you are looking your mobile, and you are looking our app, or we can say our prime courses. So it doesn't tell, this law doesn't reading your mind that how much energy you are taking from us. We are giving 100%, more than 100%, but it's totally depend on you are taking. So this law is also fail in this case. Same is like in your case, you are as this law is the limitation, same is in your case. If you are not getting 100% from our academy, or you are not utilizing your time 100%, so at this moment our first law of thermodynamics get failed. Next is it don't know, or we can say it do you know explain is sorry it don't know, or we can say don't explain the spontaneity of the process. It doesn't explain like how much extent the process can be spontaneous or spontaneous. So in this case, this law is also get failed. Or we can say it don't explain the existence of the heat engine that is having the 100% efficiency. So there is an engine that is somehow of a theoretical engine, so it is doesn't explain that this engine is having the 100% efficiency. But by the way, this engine is having not 100% energy, but we are discussing it like that it is having 100% efficiency. But I had read some book where there is a written like 99.5% of efficiency of that engine. Got it? So concept in the first law, that work done by surrounding on the system is of compression. Like suppose, as I told you, that this is a system and work done by the surrounding, like my hand is surrounding, I am just doing the work on it, I am just compressing it. So this in this case, work done by the surrounding on the system is compression, as I am compressing, and work done on surrounding by the system means this system is doing the work as, like, suppose this is opening, this is closing, so this is expanding, like system is doing the work, it can expand. Got it? So this is your work done by the system on the surrounding is expansion. So this is the typical diagram that you are able to see, that this is state first and this is state second. You are able to see here that work is done from state 1 to state second, and this leads to the decrease in the volume and the internal energy that is equal to E2 minus E1, that is Q minus W. Got it? So next is your second law of thermodynamics. So this law states that it is impossible to convert the complete heat into the work done without compensation. This law states that there is a little bit as this law come after your first law. So this law states that it is impossible to convert the complete we can say complete heat into the work done. Suppose I am it is impossible this law is also telling that it is impossible, like I am teaching you, we are teaching you, it is impossible that the efforts done by us is so percent we can say taken by you. So this law is also tell us that it is impossible to convert the work done into the heat into the work done without compensation. Means there is a little bit of compensation, like sometime you are not attending the class, sometime you get busy, sometime you are disturbing with your surroundings. So these are this compensation in between us and you. So we have to eliminate this type of compensation, and we have to be like our first law of conservation, first law of thermodynamics, that is conservation of energy, and we do not have to be think about their limitations. So please always be first law of thermodynamics, that is conservation of energy. Always be in positive attitude, like always be in a study form. Got it? Next is your Kelvin statement. What the Kelvin state? It states that it is important to use a cyclic process to exert heat from reservoir and to convert it work without transforming at the same time a certain amount of heat from the hotter to the cooler part of the body. Like this says that in a heat reservoir the work is transforming without work without transforming at the same time, like there is a little bit of consumption when the heat or we can say certain amount of heat goes from hotter to the cooler part. Next is our Carnot cycle. As the name indicate, it is example of cyclic process, and these processes are those in which a system after series of exchange return to its original position, original state. As I told you, the cyclic process means after a series process, initial and final state are same, but the Carnot cycle says that net change in internal energy is 0. Means the internal energy of the system cannot be 0. Means Q is equal to minus WC, or our work done, that is equal to net heat absorbed, and that is essential condition for a cyclic process. Means the heat that is absorbed by a process, that is equal to our work done. Got it? So this is the typical diagram of the Carnot cycle. But it is tell that it is a relationship between pressure and volume. So please be focused on this. Like this is our process that start from a point A, and it can undergo this. It can undergo to the process point B, and from point B it goes to the point C, and point C it goes to the point D, and again point D to again point A. So it is a isothermal expansion. Isothermal expansion, in this the volume get increased. Like suppose there is a volume, like volume in this case is like 5, we can say 5 ml volume we can say, or in this case it can decrease to the 20. So volume in this case can increase as the temperature remain constant during the process, because pressure and volume curve, or we can say slope, can give us the temperature. So temperature, or we can say slope of this reaction, can always remain constant. So isothermal expansion means there is an increase in the velocity, increase in the volume. Same is like in adiabatic. So adiabatic as adiabatic expansion, because expansion as there is also the increase in the volume from this point to this point, And adiabatic means the heat during this process from B to A remain constant, that is explained by your Carnot cycle. This is expansion because increase in the volume. Next is the process from C to D, that is our isothermal. That is our isothermal compression. Why this is isothermal compression? Because from this to this there is decrease in volume. That's why it is compression. Isothermal means the temperature remain constant. Next is your adiabatic compression. Adiabatic compression, like heat remain constant, but compression means the volume from this can come to the this. So please do reply that this graph is clear to you or not, or I have to repeat it again. Please reply. Okay. So next, that is our Carnot cycle. So what the Carnot theorem? Carnot theorem tell us that all the periodic machine that work in between two temperature having the same efficiency, like those machines that are operating in a specific operating between two temperature having the same efficiency, and efficiency of that machine or this type of all machines is calculated by their final temperature minus initial temperature by their final temperature, or we can say the temperature difference by their final temperature. Got it? So this is explained by our Carnot theorem. Next and last is our third law of thermodynamics. So there are four law. One is Zeroth law, first law, second law, and third law. So third law states that at absolute zero temperature, the entropy of every substance may become zero, and it doesn't become zero for a perfectly crystalline solid. So for a perfectly crystalline solid, the enthalpy or we can say the entropy of a system doesn't be zero. But for a pure we can say, but at absolute zero temperature, the entropy of every substance may become zero, because temperature is zero. As entropy we are discussing are the randomness. So it doesn't become zero, like we are taking a perfect crystal of like a diamond. So for that it cannot be zero. There is an exception, like NO, N2O, carbon monoxide, carbon dioxide, mixture of isotope and ice. These are having their zero entropy. So these are the exception, because they are having their zero entropy. Got it? Next is the conclusion of the thermodynamics law, and it tells us, like as I had explained, that the reactions that give heat to the surrounding, that is our exothermic process, means during the process the heat is evolved by the during the process to the surrounding is called exothermic process. And in this process delta H is negative, and total energy of the product is less than that of reactant. And next is like a heat reaction which accompanied by the heat absorption, or like when there is absorption of heat during the process is called endothermic reactions. And in endothermic reactions delta H is positive. Why delta H is positive? Because delta H of product is greater than that of delta H of reactant. So endothermic process are those process in which your heat is absorbed by the reaction, or exothermic are those processes in which heat is evolved during the process. Next is like how we can calculate that enthalpy of a reaction. So enthalpy of a reaction is the difference between the enthalpy of product as well as enthalpy of the reactant. As in this case, copper combined with the sulfate, or it can form copper sulfate. As we have given that enthalpy of copper is 3, sulfate is our 2, and CuSO4 copper sulfate is 9. We have to calculate enthalpy of during of all the process. So delta H is equal to 9, that is of enthalpy of product, that is our CuSO4, minus 3 plus 2, that is 3 is of enthalpy of copper, that is a reactant, and 2, that is sulfate, that is also a reactant, and enthalpy of reaction is our 4. Got it? Next is your Kirchhoff's equations. So these are the upcoming slides are the miscellaneous equations, as there was many times the question in the Gpat, NIPER and GATE exam. As Kirchhoff equation tell us, like it explain the variation of enthalpy with the temperature. So in the exam, you are able to see the questions like which of the following equation are able to give the relationship between the variation of enthalpy with respect to temperature. So Kirchhoff equation, Nernst equations, Gibbs-Free equations. So there are so many types of equations. And it says that variation of delta H of a reaction with temperature at constant pressure is equal to Cp, that is internal energy of a process at a constant temperature pressure of a system. Next is your Hess law. Hess law tells us delta G, that is enthalpy of a process, is the product of or we can say the final and initial product. It's totally depend on the final and initial product, and it doesn't on the intermediate product. As we had discussed that enthalpy of a reactions is depend on the product as well as reactant, means reactant that is the initial, product that is the final. That is also explained by our Hess law. Got it? Next is our Gibbs-Helmholtz equations. So Gibbs-Helmholtz equations, as it is applicable to all the process that are occurring at a constant temperature, and it is equal to delta Z is equal to delta H minus T delta S. Delta G is equal to Gibbs free energy, delta H is equal to your enthalpy, T is the temperature, delta G by delta T, that is your change in entropy. So this is the Gibbs-Helmholtz equation that we can applicable, that tells that it is applicable to all the process that are occurring as constant pressure, and it gives the relationship between the Gibbs free energy, entropy as well as enthalpy. Got it? Next is Gibbs-Ďuman equations. So as Gibbs-Helmholtz equation, as Gibbs-Ďuman's equation, these are two equations that are given by the two scientists in compiled form. So Gibbs-Ďuman equations state that the chemical potential of one component can affect the chemical potential of other component. So the potential that is doing by one component, or the efforts doing by one component in a reactions, is affected by this some other component, and it is equal to epsilon n1 d1 do1, or we can say for a binding system, if it contains two systems, then it is equal to n1 number of moles density, r1 the reaction rate, as well as n2 number of moles density and reaction rate of second. Got it? So this is all about your thermodynamics chapter, and next we will come with a new series or a new class of MARGDARSHAN tomorrow same time at 9 p.m. Please subscribe our YouTube channel, follow us on Instagram, follow us on Facebook, Instagram, we can say Telegram, download our app from Play Store, download you can say if you have any query, contact on the given number, or we can say join our English classes app, get our prime course of English classes for the Gpat 25, share it with your juniors. Please be active, always be happy, keep learning. All the best for your exam. Thank you everyone for joining session.